Welcome to the part 2 of the Indian monsoon session. In this lecture, we will take what are the factors behind the creation of in the formation of Indian monsoon. In the part 1, we have clearly explained the formation of winds, trade winds and all on the earth. So please go through that video lecture also if you are not aware of all the Coriolis force, trade winds and all. In this lecture, we will particularly see all the factors behind the Indian monsoon. The Indian dipole and the La Nina and El Nino conditions will be taken in the part 3. All the basic factors in the Indian monsoon will be taken in this series. So, what do you understand by monsoon? From where this term came? So, this term has been derived from an Arabic word. It means in Mausim, which means season. And after this series, monsoon series, we will take season series. Thus, you can understand how this monsoon is related with the term season. And this is mainly because of the reversal of wind. See, monsoon comes in two ways. One, there is arrival of monsoon, and one, there is a retreation of the monsoon. When the arrival of monsoon happen on the Indian coast, it happens from this direction. So this is southwest. And when the retreat of monsoon happens, the direction of the wind will be in this direction. So this will be your northeast. That's why when sailor used to come on the Indian peninsula in the earlier days, they used to come through the southwest wind and they went away from the peninsula of the India with the help of northeast wind. Okay, so the same thing mentioned here. It means initially area is dominated by northeast wind and later the same area will be dominated by southwest wind. It was easy for the sailor to sail because of these winds. Coming of the monsoon was from the southwest wind, retreation of the monsoon was from northeast wind. Okay, now the first factor, one of the first factor behind the formation of monsoon is the tropical easterly jet stream. The high pressure is present to 30 to 35 degree, but due to shifting of ITC it also gets shifted northward. What does it mean? In the first session I have clearly explained that this is your 0 degree, this is your 30 degree, this is your 60 degree and this is your 90 degree. Okay, so this 0 degree is your low pressure area, this 30 degree is your high pressure area, this 60 degree is your low pressure area, this 90 degree is your high pressure area. Okay, so the wind happens to blow from this region to this region, for here high pressure to low pressure. The same thing here, it is mentioning that in the normal scenario your ITCZ will be on where? ITCZ will be on 0 degree, that is the doldrum, intertropical convergence zone. It forms when what? When the sun rays hit directly over the equator, it creates a cool calmness in the equator, and that is known as ITCZ, where all the heats, all the vapors vaporized to low pressure, intense low pressure present. So that is here it is mentioning that high pressure in the normals, that will, when the earth moves in the northward direction, your 30 degree high pressure will also move in the northward direction and your low pressure will also move. So the low pressure will form in the 22 upon half degree north. Okay, earlier it was on 0 degree. So ITCZ will also get moved northward, and near Mascarene Islands it is absorbed that there is very high pressure, and due to this wind it gets diverged to the low pressure area. See this diagram, this is your Mascarene Island, this is your Mascarene Island. Here you will see there is a high pressure and your Indian peninsula will be at low pressure. Further, it will be intensified. This is your Tibet area. This will be a Tibet area. When it will get intense low pressure, then this high pressure wind will cause to move to the Indian peninsula, to the Tibetan plateau. Okay, that thing is mentioned here. So it is observed that there is high pressure, and due to this wind get diverged into the low pressure area. Okay, so the low pressure area is actually seen in where? It is seen where? In the Tibetan highland or plateaus. This will be your low pressure area will be seen here. This will Tibetan plateau, and further you will see Tibetan plateau is present at a height. Okay, and we know that the surface at greater height will have a greater albedo. Albedo means it will reflect much number of sun rays, thus heating will occur very high for that reason in comparison with the other reason. Why? Because if you go to the high of the mountain, the water droplets, water vapor will be very less in compared with the lowland area. Thus heating of the top of the mountains will be very easy, and this is why we see the albedo is also more, because it reflects lots of the rays or the heat during night time. So that's what it is saying, that in the Tibetan plateau is at much height, so it get heat easily because the lack of presence of water vapor and all. Okay, and this create an intense low pressure, and this sometimes extends till the India, and this low pressure tends to force to move this high pressure Mascarene island to the Tibetan plateau. Okay, see, actually what happens, let us suppose this is your Tibetan plateau and this is your Mascarene island. Okay, so what happened, air will rise above, air will rise above, air will rise above. Okay, now air will rise, it will deflect into all direction, that when it touches the troposphere, so one section will come and fall in the Mascarene island too. This is the phenomena of the wind to blow. Like as I've said, that air will blow from high pressure to the low pressure. Okay, but what happened, it like suppose this is your high pressure, this is your low pressure. So what happened, air will raise above, air will raise above, raise above, raise above. Now it will touch the troposphere. Now it has touched the troposphere, it will deflect into multiple direction, here also, in forward direction also, in the backward direction also, but it will not go downward. Okay, as it hit the troposphere, now the air will deflect, it will move into this direction, and as soon as the troposphere it is touching, it will get cool after traveling much of time. Similarly, after a period of some time, it will started to cool, and ultimately it will come and fall on the high pressure area. So that's why you will see there will be a high pressure, and now from high pressure to low pressure, we know that air will move from high pressure to low pressure, so this high pressure wind will move to this low pressure. Okay, so this forms a cycle. This is the phenomena of working. That's why we get winds throughout the globe. This is the actual basic form of that phenomena that makes wind blow throughout the globe. Okay, and due to some disturbance, sometimes when the high pressure low pressure shift, this cycle also get disturbed and it will get also shift. Okay, so the low pressure area is actually seen on the Tibetan highlands or plateaus. In the western portion, the Tibetan plateau is around 300 to 400 kilometers wide, and in the eastern side it is 1000 kilometer. So the basic point of telling this measurement is that you have to understand that how big this Tibetan plateau, and it is at highland, so you can understand that when the sun rays hit these areas, so what intensity of low pressure will be present. Okay, and Tibetan is at higher altitude, so it receives 3 to 5 degrees C more than the surrounding area, so the low pressure formation on the Tibetan plateau will be very higher in comparison with the other area. Thus, Tibet becomes hotter than the surrounding areas and low pressure is being formed. At Tibetan low pressure area, the wind will rise above. As I have explained that this is low pressure, this is high pressure. High pressure is at where? It is at Mascarene Island. Ultimately, it will rise above. It will rise above, and after hitting the troposphere, getting cooling down, it will fall down to the that is high pressure area, and high pressure area will tend to move to the low pressure area. That will lead to the intake of, that will help in the coming of monsoon. This is what, this is high pressure to low pressure. And one, I have shown you the cycle coming from the atmosphere, that this low pressure is present here, this low pressure is present here, and in the atmosphere it is coming like that. Okay, and on the ground level, on the surface level, like on the atmosphere, not top of the atmosphere, on the surface level, you will see like this direction. This is the formation of cycle. Thus, your Tibetan plateau help in intake of, incoming of monsoon in India. Okay, this is the reason, that is the tropical easterly jet stream help. So from Mascarene Island, winds towards Tibetan plateau where it get Himalayas and Western Ghats, and due to this we get orographic rainfall in these regions. So what happens, this wind, now this wind will go, this will hit the, there is Western Ghat. Now due to this we will get to see orographic rainfall. Orographic rainfall means what? There is a windward side and leeward side. So when this wind is hitting this mountain, it will be a water vapor land. When it hits the mountain, it will get rainfall in this area, but in the leeward side you won't get rainfall much here, rainfall less. So that's why it is known to be a, this type of rainfall is called as a orographic rainfall. Okay, so thus we get orographic rainfall in these regions. So wind at the surface blowing towards India, and at the top it's blowing away from India. That forms a cycle. This is what we see in the tropical easterly jet stream. Understand? This thing is mentioning that on the ground you are seeing that from Mascarene Island, that is high pressure, you are telling low pressure is going. But in the atmosphere, I have explained that in the Tibetan plateau, from the atmosphere, when the air raises, when the water vapor raises as a low pressure, it get and fall into the high pressure area. That helps in formation of cycle. That is what it is saying, that winds at the surface blowing towards India, that at the surface it is blowing towards India, that is this one, at the surface it is blowing towards India, but at the top it is blowing away from India. That at the top it is blowing from away from India, and that forms a cycle. This is what we see in a tropical easterly jet stream. Okay, so during northward movement of the sun, we observe that the intertropical convergence zone ITCZ also moves northward. So this low pressure zone will reach above 23.5 degree north. Earlier in the normal situation we will see at 0 degree equator, but as the sun moves away, tropical eastern ITCZ will move to the 23.5 degree north. It is not like that 0 degree will not be in low pressure. It will be in low pressure, but the comparison with the ITCZ, it will not. So in South Asia, that is our India and all, in South Asia it reaches above Himalayas and will hit the Tibetan plateau. Okay, what is saying, that this shifting of ITCZ will that intense, the shifting of ITCZ will be that intense that it crosses the Himalaya. It will cross the Himalaya. Earlier the ITCZ was present here, but now the shifting of the sun rays as the rotation and revolution of the earth, you will get at 23.5 degree. You will get at 23.5 degree sun rays. Now your ITCZ will be around here, and this hitting will be so intense that it sometimes crosses the Himalayas and hit this Tibetan plateau. Okay, it will hit this Tibetan plateau. So the Tibetan plateau is a huge mass which extends to almost 2000 kilometer from west to east, and the plateau is at height of 4000 meters. The same thing that I mentioned here, that it is the altitude is 4000 meters, and thus it receives more sunlight. So usually if we compare the 2 degree to 4 degree or 3 to 5 degree C, it will be more compared to the surroundings area. So this plateau becomes a source of low pressure during summer. Okay, so due to the northward shifting of the sun, the high pressure cell in subtropical region also move northward, and during this, high pressure develops at 25 degrees south near Mascarene Island. Okay, so what is this line tried to explain? This line tried to explain that, as we have said, that now the shifting of the earths happen. Like, let me draw again. Like, this is your globe, this is your 0 degree, this is your 30, this is your 60, and this is your 90. Okay, similarly here we have 30, here we have 60, and here we have 90. Now your ITCZ is shifting to the in the normal condition, this is your low pressure, this is your high pressure, this is your low pressure, this is your high pressure. Now your sun rays is shifting, your ITCZ is shifting here. Ultimately this low pressure will also shift above, na? Your low pressure will also shift, and here also in normal condition it was like that. Now the same thing will happen, everything will shift above, everything will shift above. That is, it is mentioned that now earlier you had on the 30 degree you have low pressure, okay, but as the subtropical region, as the move northward, your high pressure now will develop at 25 degrees south. Earlier it was at 30 degrees south, but now it will move to the 25 degrees south near Mascarene Island. So on the globe, when we see, the 25 degrees south will be present here, so it will form Mascarene Island. Okay, here see, this will be 30 degree, now it will shift to the 25 degree, so ultimately your Mascarene Island will be affected. Okay, so the high pressure will be developed near Mascarene Island, and hence we call this high pressure as a Mascarene high. So the high pressure will lead to subsidence of air, and low pressure will lead to rising of air. A convection current and the cellular cells occur between Tibetan low pressure and Mascarene high pressure. I have explained, in the air, from the Tibetan, air will rise above, it will get, and it will found in the Mascarene Island, and from the Mascarene on the surface you will get monsoon intake from the high pressure to the low pressure. So if Mascarene high and Tibetan low pressure difference is more, then the pressure gradient force will be intense, and hence we get good monsoon. Understand what is saying? It is saying that, let us suppose your Tibetan plateau is not heated too much, so the low pressure created on the Tibetan plateau, the low pressure created on this Tibetan plateau will be less. So ultimately the falling of this low pressure into Mascarene Island will be not so much intense, because low pressure is not so much intense, because this intake of cycle is depend upon what? It is depending upon the Tibetan low pressure. Okay, now your Tibetan low pressure is small, so how will you get an intake of good monsoon? That is what I mentioned. Like, if we have a very high low pressure on the Tibetan plateau, then we will get intense convergence zones, like we will get intense, see what are you saying, we will get that high gradient force, the convection current will be high, and ultimately as this will be high, we will get huge, that good monsoon, a speedy monsoon in that area. Okay, this will get speedy monsoon, this will help push the monsoon more speed, and hence we will get good rainfall in that year if the Tibetan plateau is at very high low pressure, if it is getting very deep intense low pressure. Okay, so this is what tropical easterly jet stream. Now we will move to the second equatorial trough. What is this? We will see. See, during summer the North India will be heated, and there will be low pressure cell developed. Okay, your North India part will be heated too much, and here will be have low pressure cell. This cell, when it merges with the ITCZ, Tibetan low pressure, then the difference between low pressure and high pressure in the easterly jet stream will be more, and thus the wind monsoon movement will be intense. Okay, so if it does not merge, the movement monsoon will be weaker. What is it saying? That, see, in the tropical easterly jet stream, I have explained that from it here it will come and it will fall down, and if your Tibetan plateau will be intense low pressure, then it will be very good monsoon. Now suppose your Indian plateau will also be heated. Till now we are talking about Tibetan plateau. Now your Indian plateau will also be heated, and if this heat get merged with the Tibetan heat, like if it went to the Himalayas and all, if it merged with the Tibetan heat, ultimately the intensity of the low pressure will increase very efficiently. That's what it is saying, that when it merges with the ITCZ or Tibetan low pressure with the what, with the Indian low pressure, then it will get very high, very good monsoon intake, and if it does not get much, the monsoon will be weaker. Okay, so this equatorial trough, this one means low pressure area or the doldrum. We observed when ITCZ is moving above the equatorial low pressure, it is not moving above, like ITCZ is moving above, the equatorial low pressure is not moving above. That is what it want to mention, like at equator 0 degree there will be a low pressure. It is not like that there will not be low pressure and the sun has been completely moved, but the ITCZ has moved. Equatorial low pressure is that earlier ITCZ will also forms at the equator only, but now ITCZ has moved and equator has a low pressure also. So the sunlight is spread so that equatorial trough does not merge with the ITCZ. Okay, that means all the sun rays does not fall completely on the Tibetan plateau. Some of the sun rays also fall on the Indian plateau. That is what it trying to mention, that Indian region will also be heated, and when this equatorial trough and ITCZ meet, okay, that ITCZ means that Tibetan plateau, when this equatorial trough, that from equator or the Indian land will be heating up, when these two things will meet, the low pressure area will be more, and this will bring good amount of monsoon rainfall in India. That is something called the second equatorial trough. Okay, now we have seen this diagram too much, so okay, it will be friendly to you right now. So now the Somali current and Somalia jet stream. Okay, see what happened, I have explained it already. The same thing will be here, that now this, what happened now from the Australia when you have a low pressure, so as I have explained that from low pressure it will raise above and it will fall on what, it will fall on the high pressure in the atmosphere when it hit the troposphere and all, and ultimately this high pressure, this will move here, and there will be intense another trade winds will come from the Somali jet stream. Another Somali jet will come, and when this Somali jet will hit this wind, it will create an intense push of the monsoon, and it will give rainfall to the India. That is what Somali jet stream. So as per this slide, Somali current is an ocean current which is present at the Horn of Africa, that is here. Okay, this one, it is present at above the equator. So if you see, this will be your above equator is this one, this is present above equator. Okay, when wind blows from tropical to equator, the ocean flows in the direction and it is cooler, and when wind blows from equator to tropic, the ocean flows in that direction and it will be warmer. What is saying? That we have monsoon return also, so it comes into which direction? It comes into the northeast direction. So when the monsoon return, so it is coming what? It is coming from cool to warm. So it is saying that when wind blows from tropical to equator, this is from tropic to equator, the ocean flows in the direction and it is cooler. In this way we will get cooler ocean waves. Cooler means it does not seem like it will be cool like ice in comparison with the water present at equator and water present at this area. It will be cooler. Okay, and when the wind blows from equator to tropic, that equator to tropic, it will be a warmer. Okay, now in the Horn of Africa, this region, better color, in this region we will see all the colors are same. So in the Horn of Africa, ocean current get accumulated near Somalia. Here it will be accumulated here, Somalia, and it intensify ocean current, which causes the region warmer and low pressure area get develops. What happen in the Horn of Africa? Your water will be getting accumulated and it will be heated up, and as soon as, just note one thing, the heating of land, when a temperature like when 20 degrees Celsius is heating a land and when 20 degrees Celsius is heating a water, your land will be heated early, your water will not be heated as much. Okay, just keep that in mind. So your land will be heated, intensified ocean current, which causes the region warmer and low pressure area will get developed in the Horn of Africa region, region. Okay, and heating of land and water is different. On land low pressure will be more, and at the same temperature and water will be more. I have explained it here. Okay, so thus this jet stream are formed at Somalia are at lower height and will have significant effect on the wind which blows. What is it trying to say? That this is your Somalia. Okay, water is getting accumulated here. Now I have said that heating of water will at the temperature X will be less compared with the land. Okay, so water that will be heated, that will not be much hotter, but it will get water vapor formation. Okay, what does it trying to say? That when the water vapor will evaporate from the Horn of Africa, it will get cooler at very low height. It will not move to another regions and all. It will get cool at low atmosphere only. Okay, that is trying to say that it will get cooler on the low atmosphere only, and this will merge in, this will get a push to the monsoon. This will help in pushing the monsoon. So this is what this jet streams that formed as Somalia and at lower height. This will have a significant effects on the wind which blows. So Somali jet stream, once it raises above, when it will be raised above, it get divided into two parts. One will be a Mediterranean Sea that will go into your Arabian Sea and all, and other will be in the Indian Ocean. Okay, this will raise above, and one will be going to the Mediterranean Sea and Arabian Sea and all, and other will be go to your Indian Ocean. The southwest wind, this is this southwest wind, and Somali jet stream comes in the same direction. This Somali jet stream is also coming in the same direction, and this your southwest wind will also coming in the same direction for other division. Okay, as soon as the Somali jet stream get formed, the intensity of the monsoon will be more, and thus monsoon hitting on the Indian island will be high. That is what it is trying to explain, that how Somali jet stream is helping here. One, you will get in the Tibetan plateau, that is first you have get the tropical easterly jet stream where your Tibetan plateau is getting heated and it is getting help from this Mascarene island. In the second case, Indian land is helping when second equatorial trough, when it get merged with the ITCZ, then it is helping in intense heating of the Tibetan plateau. Okay, in the third one, the Somali current is forming, that in the Somalia, when the water is getting accumulated, it will create intense low pressure and this water will raise, but this water vapor will not raise at much height, and ultimately this will move in the two direction. One will be in the Arabian Sea and another will be the Indian Ocean, and Indian Ocean already had a southwest monsoon in the same direction. This Somali jet stream will give a intense heat, then another push to the monsoon, and ultimately we will have a good monsoon on the Indian soil. So during monsoon season in the northern Indian Ocean, we observe that the ocean current also changes their direction. When ocean current changes their direction, currents move from equator to tropics. In this case, equator to tropics, which are warmer than regular current. Due to this, low pressure cell will be developed near Somalia. Like this, all the water, if you see this diagram clearly, see this arrow is there, and why this is arrow I will explain it here. Because of this low pressure, because of this low pressure, and you will have this will be high pressure and this will be a low pressure. So that's why we will see this water will be getting here, it is going to the low pressure, and this is a warmer water, and as soon as this warmer water will hit the Somalia, it will get intense low pressure will be created and it will get evaporated. So when the ocean current changes their direction, move from equator to tropics, which are warmer than regular current. Due to this, low pressure cell will be developed near Somalia as the water piles up here, and this cell is formed during the summer only. It is not in the winter and all. It will form in the summer only when your sun has moved northward ITCZ. So the rising air at lower altitude form jet stream and move northward, and it is usually divided into two branches. One enter into the Arabian Sea Peninsula or Mediterranean Sea region, and the second moves towards the Indian subcontinent. As the direction between the Somali jet stream and the southwest monsoon are same, the intensity of the monsoon movement is increased, so it will bring the good rainfall in the Indian subcontinent. Okay, so your Mediterranean Sea in these regions, and this is your Arabian Sea. So two division will happen, one will go to the Arabian Sea, another will go to the Indian Ocean. And when it go to the Indian Ocean, we already have a southwest monsoon, and it is happening in the summertime, and in the summer only we receive the monsoon. So thus this Somali jet stream will give an intense another push to the monsoon, and ultimately we will have a good monsoon in the India. Okay, so this is explained here that in the figure we can observe below the equator wind in the left direction, then it turns in the right direction. See, this is what is in that. In the figure we can observe below the equator wind, this equator wind, we know below the equator the south west trade wind will be there. Okay, this one southeast trade wind, here the wind will be like that, and here the wind will be like that. Okay, so we will have a southwest trade wind, southeast trade wind. So this will get in this direction. So below the equator wind, it will blow in the left direction, and thus it turns in the right direction here. Now after this here it will hit, and it will hit in the right direction. So this will be your forms of southwest trade wind. Okay, so first it will be, once again I will explain it clearly. So first it will be in southeast, then it will turn in the southwest. Okay, this one, when in the retreating of monsoon, that this is your southeast, this is your southeast, and then it will turn into the southwest. Understand what he is trying to say? That first it is in southeast, then it will turn in southwest. At Tibetan Plateau there is low pressure, and if the difference between high pressure and low pressure is more, the pressure gradient force will be more, thus the intensity of the monsoon will be more. Here it is again that is colliding with the Tibetan Plateau. Okay, and if Tibet when sun rays are distributed throughout not only Tibetan but all the Indian, so the intensity will be less. And in Somali jet stream, due to the southwest monsoon or the southwest trade wind, this wind, this southwest trade wind, it blows from equator to the tropics. Somali jet stream will give push to the wind, and if Somali is stronger than the monsoon, it will get stronger. At 30 degrees south we will observe high pressure in the normal area. So ignore this para, this will not relevant with the Somali jet stream, but it is relevant with the first part, that is the tropical easterly jet stream. Okay, so that is what Somali jet stream is helping. This is not Somali. So these three things we have seen, that tropical easterly jet stream where the Tibetan Plateau is hitting intense pressure and it is causing the coming of monsoon. Second is second equatorial trough, that is when hitting of Indian land will open, then ITCZ will merge with the Indian low trough, that is equatorial trough, and this will create intense low pressure, then this will help in coming of the monsoon. Then the third will be Somali current, that when the water will get piled up at the Somalia regions, then it will be get low pressure area, the water will raise above, but the heating of the water compared with the land will be low. So thus it will not attain such height for cooling down, and it will move into the two direction. One will be in the Arabian Sea or Mediterranean Sea direction, and another will be to the Indian Ocean. And this is happening in the summer season, and in the summer season we know that monsoon will come, and ultimately it will get merged with the monsoon. That thus it will get a new push to the monsoon, and thus the Indian land will receive a very good rainfall in that year. Okay, that is Somali jet stream. Now we will see permanent jet stream. It is also called a subtropical jet stream in the northern hemisphere. Okay, now what happens? See, this is, if you see this figure, this is moving in what? In the sinus manner. Why this is sinus manner? This trough, this downward movement is happening because of polar cold wind. So that's why you will see here this push is because of polar wind coming from North Pole, and again this raising above is forming because of the heating from the equator, the heat coming from the equator. Again here heat coming from the equator. So this is going with the in northern hemisphere, because it has been observed that is polar wind comes till India also, till crosses 30° north also. It is coming from 90° north to 30° north also sometimes. So that is what that helps in formation of the permanent jet stream. That is explained here, that when we have this type of things, the warm air will rise above. So this will make wind to move above. Why it is moving above? Because what happens when we heat water, it will raise above, and it will raise above for what? It will raise above for cooling down, and the amount of the quantity of water and what temperature it has been heated up. If it is more heated, it will attain more height to cool down. Understand this thing. Like suppose there is a water droplet, it is heated from 20° Celsius, okay, and there is another water droplet, it is heated at 10° Celsius, okay. So both will raise above, water vapor will form, but for cooling down of this water droplet, that is at 10° Celsius, it will cool down at less height because it is less temperature. It will come to 0° Celsius or 1° Celsius very in less height only. So the height for this one will be less, and for the height for attaining for this 20° Celsius water droplet will be higher as compared with that one. So that's why it depends that warmer air will cool down at much height, okay, and the cold air, when it will come down, it will push the air downward, that high pressure will come down, okay. And whenever see warmer air, it will, if there is ocean present, then we can see the formation of rainfall, but in the colder air regions mass we won't see rainfall much, okay. What is in this slide? With this permanent jet stream, we have 4 permanent jet stream. What are the 4 permanent jet stream? 2 at the polar, northward and southward, and 2 at the subtropical region, okay. Both the tropical. So we will have 2 at the subtropical region. So the jet stream used to move in the parallel straight path above, but due to cold air mass this one and warm air mass this one, this mass acting on it above and slow, we will see a sinus movement of the wave. See, this is the sinus movement, okay. So it has been observed that jet stream moving in a sinus wave. So due to this alternating low pressure and the high pressure present, air masses are present at very large area, and the area under high pressure will have no rainfall. This area will have no rainfall, and low pressure area will have a high rainfall. That's why when the Tibetan plateau will be heated up, then it will bring monsoon here and it will get rainfall. That's why we are saying that it will get high rainfall. And sometimes we will see that polar jet stream comes till Madhya Pradesh, till Himalaya, it crosses Himalaya and all. And when this colder air comes till the Himalayas and all, in this year we will see less rainfall. That is also one of the reason of formation of lesser. That in the news you will hear sometime that this year too much cold is there, a polar wind is coming here. So the intensity of the coming from the polar winter, it sometimes crosses the Himalaya and hit till the Madhya Pradesh and all regions. Okay, so you can understand this permanent jet stream is also playing one of the significant role in intake of monsoon, because again monsoon have to make cool down that warm that region. That now we will say that polar wind is still Madhya Pradesh and now the monsoon is hitting down. Monsoon have to collide with this one and it have to evaporate these all things. It have to heat those regions. Okay, and this heating will happen suddenly. We will see in this slide. So the subtropical jet stream is present over North India, that's coming from there, and high pressure area is being developed over North India when it comes down, and this is during normal period. During summer, as I've explained, that during summer the ITC jet will shift. Now the warm air mass will also shift northward, not from equator. This will move. Now it will start hitting those regions. Here it will Madhya Pradesh and all. It will start hitting those regions, and we are seeing that subtropical jet stream is there. So during summer ITC jet will shift northward. Then warm air will also shift northward, and jet stream will be high, and it will be move above Himalayas. So again you will see that suddenly this will disappear. This polar jet stream will disappear, and you will get monsoon hitting again Himalaya regions and all. You will get rainfall and all. So for that, first high pressure should be disappear, and this monsoon will do so, and it will happen suddenly. Okay, so the subtropical jet stream in northern hemisphere, that is coming from the polar region. So these traveling depression jet stream are moved southward, northward due to the action of cold air mass and warm air mass respectively. Same thing explaining it here in the easy language. So during winter the action of cold air mass will be stronger and would push the jet stream over North India. Okay, during the winter the action of cold air mass will be stronger and it will push to the North India. Wait for a second, I will pause here and I will explain it one more thing. There is one technical glitch is happening, sound recording issue. Sorry for this small technical glitch. So due to the presence of cold air mass, that cold air mass will be stronger, would push the jet stream over the North India. So due to the presence of cold air mass, the area experience high pressure and hence no rainfall, and with the northward movement of the sun the cold air mass becomes weaker and warm air mass will become stronger. So first the warm air mass pushes the jet stream northward, that the jet stream that we have in the north area that is coming from the polar wind, it will push it in the northward and they will hit the Himalayas and the Tibetan plateaus, and this will divide into two streams also. So one moving for the northward that one will move for the Himalayas and other will move from the south of Himalaya. That is one, if you have, this is Himalaya, so one will into this direction, one will the Indian side, that is the northern side, this is northern side, this is the southern side. So one will come to the south of Himalayas, and until the jet stream is present over North India, rainfall will not be seen, and when the ITC jet will happen, suddenly this jet stream will disappear and you will get burst of monsoon, that with the further intense warm air mass pushing the jet stream over Himalayas. Like now your summer is coming, your sunrise is moving northward, your ITC jet is coming here. Now what will happen, that polar wind is there, okay, coolness is there, it will get heat up, and this will heat it up suddenly, the jet stream above Himalaya, and this will, as soon as this will heat it up, this will create intense low pressure develop, and this leads to the convection current and intense rainfall, and this is known as the burst of monsoon. Understand that? Again I will explain the basic term, that this is your Himalaya, you have a polar jet stream in the India. Now sunrise is coming above, now heating of the Indian land will happen. Now this heating of the Indian land will happen, what will it do? It will move, it will force this jet stream to move Himalayan side, Himalayan regions, and ultimately at one point it will happen that it will suddenly disappear, this jet stream will suddenly disappear, and because of the high pressure, if the high pressure is there, you won't see rainfall, and thus it will suddenly disappear, it will create low pressure and you will get a burst of rainfall at that time. Okay, so in the simple terms, this is explained here again. So in simple terms, that when southward movement of the sun in northern hemisphere happens, cold air mass will push jet stream over Indian subcontinent, that this one. In this one it is coming from north wind, and if it is in India, okay. So this northern hemisphere, the cold air mass will push jet stream over Indian subcontinent. Due to this, usually we don't see any rainfall. That is, in winters no rainfall is absorbed. The other, that is, we that the some parts of area that will receive rainfall in the winter, it is because of the retreating monsoon, okay, but not because of those, that jet stream. So we observe some regions like Rajasthan, UP get rainfall during this time. It is because of the subtropical jet stream carrying moisture from the Mediterranean Sea, that is from these regions. These areas will receive rainfall because of the Mediterranean Sea, and another Kerala regions will receive rainfall because of the retreating of monsoon. But the mainland India will not receive rainfall in the winter, okay. And it is called western disturbance, so that when you are Rajasthan and all, you are getting rainfall because of the Mediterranean Sea and all, so that is known to be a western disturbance, and it happens in the winter time. So this moisture gives rainfall in northern western part of the India in winter, but for the Indian subcontinent mainstream it doesn't give rainfall, okay. So now in the northward movement of the sun, warm air mass push the jet stream that is present on the Indian subcontinent, that is not allowing rainfall here, that is creating high pressure zone. So the jet stream will behind the Himalayas, and the area will be under low pressure, and it will get good rainfall. Usually even during the northward movement of the sun, there may be an action of cold wind or cold air mass, and whenever cold air mass impact is more, then warm air mass impact will less. That when this cold air mass impact will be less, then you will get less rainfall, okay. So it happens during the monsoon period. When it comes to the North India, rainfall does not happen. This is called breaks in monsoon. Like it is saying that, okay, summer is coming, it is hitting the land of India, okay, and you have a jet stream, polar jet stream is present here, and let us suppose now the summer is hitting, but the intense heating is not taking place. It means what? That polar jet stream is more stronger than the intense heating of the land. So ultimately what happens? You will not get rainfall because there is high pressure, and this is something known as break in monsoon, okay. So in winter, when the jet stream divide into two branches, that is into Himalayas above and below will be come in the Indian region. So due to this jet stream present, we can't see rainfall in the northern India. Even monsoon had arrived, even monsoon is region, we won't see rainfall because there is a high pressure zone is in India, and it is stronger. So but due to intense heating, when there will be sudden low pressure and disappearance of jet stream, if intense heating take place, then will sudden low pressure zone. Like see, no rainfall you will see not every time. So in some year it happens like that, but every year this phenomena occurs and intense heating taking place, and ultimately this will help in the burst of monsoon. So this low pressure will lead to raise the air very quickly, and southwest trade wind, this one after crossing 0 degree equator, we will see this one till 30 degree and all, that is, yeah, till 30 degree and all, it will cross 35 degree also. So southwest trend will moving at particular height, but raising above, they will cross their dew point, and it will lead to sudden burst of rainfall. Why it is known dew point? Dew point means, as I explained, that dew point will, you will get water droplets directly, it will turn in water vapor into the water droplets. That when intense heating is taking place, that's why it is telling that sudden burst of rainfall is happening, because we have a polar jet stream, it is high pressure, it has the water vapor too. So now it is heating takes place, and it will ultimately touch the dew point, and thus it will give a sudden burst of the rainfall. Thus this is associated with the permanent jet stream, okay. So I hope you understand this. In the coming next part, we will take Indian dipole and the El Nino and La Nina effect, okay. Please like and subscribe. Your subscription is a form of payment for me. If you have any suggestions, please feel free to ping on my Twitter handle. I will be ready to help you. Thank you.